Hi everyone, now we are at lecture number 11, Integral Calculus. So in this lecture, we are going to learn about a spherical polar coordinate system. So if the solid of integration is a sphere or a portion of a sphere, then this coordinate system is most useful. So under this coordinate system, we can evaluate the trivial integrals easily, like what we have done earlier in cylindrical polar coordinate system. Okay, now let us enter into the topic. So suppose x, y, z are related to three variables rho, theta and pi through the relations x is equal to rho sin pi cos theta and y is equal to rho sin pi sin theta and z is equal to rho cos pi. Look at now the old variable is in Cartesian coordinate system x, y, z. Now the new variable in spherical polar coordinate system is rho theta pi. Here new variable is rho theta pi. Look at x is in terms of rho pi theta. Here also rho pi theta. Here rho and pi. So completely x, y, z are in terms of rho theta pi. So it is changing variable x, y, z to rho theta pi. That is called spherical polar coordinate system. Then such a triplet are called spherical polar coordinates, and these spherical polar coordinates will be obtained by using this following figure. Now look at how we can obtain such three transformations, this x, y and this z. Now look at one by one first. So in these three variables, what is the first one? Rho, right? So first one is rho, next theta, next pi, or you can interchange these two, rho, pi, theta also can write, no problem. First one is rho. Okay, look at rho is the distance from the origin. So this is the distance. Look at here. So this is a distance from where? From origin. Generally it called 3D radius, in other words. So which point? The point x comma y comma z. So distance between origin to that point x comma y comma z, because this point is x comma y comma z. What is this point? This point is x comma y. Look at this length is x units and this length is y units. So total this point, location of this point is x comma y. So location of this point will be x comma y comma z. So the distance between origin and this point will be rho. That is the first variable rho. And what about theta? So theta measures from the positive x-axis. So this is a theta. Okay. So theta is an angle between r-axis to positive x-axis. This is positive x-axis and this is r-axis. So angle between positive x-axis and this r-axis is nothing but theta, and it can measure from positive x-axis to the direction of positive y-axis. This is y-axis. Okay. So theta measures from the positive x-axis in the direction of the positive y-axis. And the last one, pi. So pi measures from the positive z-axis. Now look at the graph. So this is pi, right? So this pi is starting from where? It measures from positive z-axis. This is z-axis. So you have to count from here to here like this. Whereas theta measures from positive x-axis to the direction of positive y-axis. Therefore, it has to measure like this. Like this it has to measure. But here, pi is measuring from z-axis, positive z-axis to this rho axis. So angle between rho axis and z-axis is pi, and it measures from positive z-axis. And this rho axis spreads around z-axis. So if this rho axis moves from z-axis like this, starting from z-axis and spreading like this, so it spreads in all directions. Around z it will spread, not only in this direction, anti-clockwise direction. Around z this axis will spread, so that, look at now, so this rho axis starts from here, so like this it spreads. So immediately what figure is generating? It is generating a sphere only, right? Like this also. Around z it spreads like this. For example, look at this is z axis. Okay. And now this is rho axis. Now it spreads like this. Like this it spreads. So indirectly a sphere is generating like this. Okay. So like that. So rho spreads around z axis. I will show you in the animation video so that it will be very clear about rho, theta and pi. Now look at how how these transformations are obtained. So this point is x comma y. So this is x comma y, right? Because it is in 2D. This is in 2D xy plane. Now come to 3D. So this point is x comma y comma z. X comma y comma z. Z coordinate is included extra. This is vertical distance. And moreover, look at, if you consider this strip, for example, look at this. I am considering this strip. If you consider this strip, look at this strip. If you consider this strip, what we assumed in cylindrical polar coordinate system. If you take this strip and if you move this strip, this sheet around z-axis, then cylinder will be generated. But this is not cylindrical polar coordinate system, right? It is a spherical polar coordinate system. Therefore, we should not consider uh, this vertical strip and this sheet. Okay, so instead of considering this sheet, I am considering this rho axis. So that rho axis is moving from the positive z-axis or around z-axis, so that a sphere will be generated. Right? Now let's look at how the transformations are obtained here. Okay. So before that, what is x and y here? So from this xy plane, so x is equal to r cos theta, right? And y is equal to r sin theta. R sin theta. So directly this length, right? So this length is r cos theta, this length, right? So this length is r cos theta and this length is r sin theta, because the point is making an angle theta with respect to positive x-axis and having the distance r units. That's why this point x coordinate will be r cos theta and y coordinate will be r sin theta. Over. Now let us focus on this x comma y comma z in terms of rho theta pi. So, but here in terms of r and theta, right? So r we don't want. So r in terms of rho I need to substitute. Understand? Because rho axis need to be varied to generate sphere. I will show you in the animation video. So therefore r we need to substitute in terms of rho. So now let's look at this triangle. Consider the triangle. So right. So what is this? This is z, right? Look at this length is z from here to here, right? Next this one, it is r, right? Look at this blue one, this length is r, therefore this length is also r, therefore this length is r, so therefore this is r, this is r. And what about this? This is rho. So angle between z and rho will be pi. This is pi. Okay, let us look at this one. Okay, I am rotating the same figure like this, so that this will be z, and what is the hypotenuse? Hypotenuse will be rho, and this will be r. The angle between rho and z will be pi, so therefore this will be pi. So this is pi. Okay, and this is 90 degrees, right? So this is 90 degrees. So r and z, between r and z, so this is 90 degrees. Angle between r and z, so angle between r and z is 90 degrees, right? Now from this figure, what is sin pi? Opposite side by hypotenuse. So rho by pi. Okay, rho by r by rho. Now what is r value? In this, r is equal to rho sin pi. R is equal to rho sin pi. Look at, I'm finding r in terms of rho and pi. Look at, so r completely going to replace here. Next one. Okay, so if r is equal to rho sin pi, what about this x and y? So x is equal to r cos theta, y is equal to r sin theta. So instead of r, you substitute this fellow, rho into sin pi. So that what will you get? So therefore, since x is equals to r cos theta, so r we are replacing in terms of rho and pi. So this will be what will you get? X is equals to r will be rho sin pi. So rho sin pi cos theta. Okay, and similarly, what is y here? Y is equal to r sin theta. Y is equal to r sin theta. And what about this one? And same story. Instead of r, let us plug in back rho sin pi. Rho sin pi cos theta here. Okay, cos theta, right? And more, what I want z, right? What should be z? Z is question mark. So therefore z will be, what is z now? Go back. Look at from the same figure only. Now look at what is cos pi. So base by hypotenuse, right? So z by rho. So why I am writing only cos? Because I need to involve the coordinate z. Earlier I have not involved z, I have involved r. Why? Because here I want r. So these two things I have taken intentionally. So first x and y, after that z coordinate. So therefore z is equal from here, which is rho cos phi, which is rho cos phi. Look at the transformation here. So z is equal to here, rho cos phi here, rho cos phi. That's what. So therefore z is equals to here rho cos phi. Okay. So let's call this is equation number 1, this is equation number 2. So these three are transformations. So under these three transformations, a Cartesian coordinate system will be converted into spherical polar coordinate system. So a Cartesian coordinate system, coordinate system will be converted into spherical polar coordinate system, spherical polar coordinate system by using the above three transformations, the above equations 1, 2 and 3. So under these transformations, a Cartesian integral will be converted into spherical integral. So now look at how the integration modifies, or how the integration is carried out under these three transformations. So triple integration, okay, over R. So this R is a region in which x comma y comma z varies. So the function f of x comma y comma z and dx dy dz, dx dy dz, and this will be, so how it modifies, so triple integration over s I am writing. So s is a region in which rho theta pi can vary. What do you have to do? We have to change the variable x y z in terms of rho theta pi. Now instead of x, let us substitute this transformation rho sin pi cos theta. Therefore substitute here rho sin pi cos theta, comma. Next y is equal to rho sin pi sin theta. You can remember these three transformations easily if you remember r is equal to rho sin pi. Just you have to replace here only. R cos theta and R sin pi. R is rho sin pi, here rho sin pi, here rho sin pi, here obviously rho cos pi. And z value is rho cos pi. Right. Into Jacobian, right? Jacobian, but which should be in modulus. Jacobian and d rho into d theta into d phi. So indirectly this will be triple integration, right, over the region S, over the solid S. So let's call this entire function is some let's call alpha of, so it's a new function, right, in terms of rho theta and pi, I'm calling that function is some alpha. Same this function only I'm renaming. Okay, rho, let me rewrite this. So alpha of rho theta pi into Jacobian. So I need to compute what is Jacobian next. So modulus of Jacobian into d rho d theta into d phi. Okay. So here R is a solid in which x comma y comma z can vary, and S is a solid in which rho theta and pi can vary. Okay. So this is a new solid of integration, and this new solid, it may be shrink or it may be expand. So but overall by this Jacobian, these integrals will be adjusted. Now look at graphically how these three coordinates, how these three transformations will be generated a sphere. So why the name spherical polar coordinate system? Why the name spherical polar coordinate system? So by using one animation video, I will convince you under these three transformations how a sphere will be generated. Look at now. So let's look at this. So let's take this is a point in 3D. So this length x units and this length y units and this length is z units. Okay. So now this point is x comma y comma z, right? So what we defined rho? Rho is nothing but the distance between origin and this point. So now this is my rho. This distance is rho. And what about this? This is r axis. Make an angle theta with respect to positive x axis. It moves like this. In the xy plane, it moves. Okay, like this it moves. So that you imagine hemisphere, the bottom shape will be circular kind of thing. So that will be generated through this angle theta. Okay. Next, the angle between rho and z axis is pi. So this is pi and it moves like this. So this rho axis starts from z axis. Not on z, around z it starts. Around z axis like this. Okay. Around z axis it moves and it spreads around z. So like this it spreads. So that a solid sphere can be generated. Look at hemisphere is generated till xy plane. Okay, like this. So therefore r is spreading around z. Similarly, it goes down so that entire sphere will be generated. So far hemisphere is generated. Now full sphere. So like this. So look at indirectly this kind of figure is generating. Understand? So this kind of figure is generating around z axis. Since it is 3D, so it's looking like a circle, but it is not a circle, it is a sphere. Look at it is a sphere. So because of this rho axis around z. Hope you understood. So next let us compute the Jacobian. So Jacobian for spherical polar coordinates. So first of all, what are the transformations? X is equal to rho sin pi r cos theta, right? Rho sin pi cos theta. And what about y? Y is equal to rho sin pi sin theta, right? Rho sin pi sin theta. Rho sin pi sin theta. And what about z? Z will be rho cos pi. Rho cos pi. Right? Now, what is Jacobian? So Jacobian is, what is that? Partial derivative of x comma y comma z with respect to rho, theta and pi. Okay. Yeah. Now let us find rho about x. Right. So first row about x. So therefore this will be dou x by dou rho. Next dou x by dou theta. Next dou x by dou pi. Next second row with respect to second row about y. So dou y by dou rho. Next dou y by dou theta, right? Next dou y by dou pi. Okay, and third row about z. So dou z by dou rho and dou z by dou theta and dou z by dou pi. Okay, let's plug in all these unknowns. So this will be, yeah, yes. So first row about x. So dou x by dou rho. Concentrate on this first transformation. Dou x by dou rho. With respect to rho, you have to derivative, partial derivative. So sin pi cos theta. So this will be sin pi cos theta. Okay. Next dou x by dou theta. With respect to theta, it will be minus. So minus rho sin pi sin theta. This cos derivative minus sin theta. So that minus is adjusted here. Next, third entry 1 and 3. 1 comma 3 entry. Dou x by dou pi. With respect to pi. So it is rho sin pi derivative cos pi, rho cos pi, and cos theta as it is. With respect to pi, we are doing derivative. Okay. Next, with respect to next about y. Now concentrate on the second transformation. Y is equal to rho sin pi sin theta. Now what is dou y by dou rho? Dou y by dou rho. With respect to rho, it is sin pi sin theta. Okay. Next 2 comma 2 integrate. Second row, second column. Dou y by dou theta. Dou y by dou theta. So rho sin pi cos theta. Okay. Next one, dou y by dou pi. So rho cos pi sin theta. Okay. And next one, and the last one about z. So dou z by dou rho, which is cos pi. Next, dou z by dou theta. There is no theta, therefore this is 0. Okay. Next one, dou z by dou pi. So minus rho sin pi. That's it. So find out this determinant. Since you got 0 here, you will get easily. So you're supposed to get rho square sin pi. You will get. Once you try, you will get rho square sin pi. Okay, this is Jacobian. Okay, so from now onwards, I will use Jacobian in spherical polar coordinate system will be rho square sin pi. Okay, so next substitute back this Jacobian into the triple integration. So final form of the integration under the spherical polar coordinate system. So this R, so f of x comma y comma z, dx, dy, dz. Okay, and this will be, so triple integration over s. Okay, over s. What is that? Alpha of rho, theta, and pi. Okay, and Jacobian, right? So Jacobian should be in modulus. Okay, next d rho, d theta, and d pi. So this Jacobian we have to substitute back. So therefore triple integration over s, right? So alpha of rho comma theta comma pi, and what is Jacobian now? Just now we got that is rho square sin pi. So therefore rho square sin pi. So if you are getting minus rho square sin pi, you have to take only modulus thing. That means you have to take only positive value. Okay, d rho, d theta, d pi. Okay, so therefore a spherical polar coordinate system, is most useful if the solid of integration is a portion of a cylinder, a sphere or a sphere. Okay, then this spherical polar coordinate system is most useful. Okay, so now let's have some problems related to this spherical polar coordinate system. So problem number 1, evaluate the triple integral x into dx dy dz over a sphere of radius 1. So first, let me sketch a rough diagram. So assume the rough diagram. Right. So let's extend this. So this is, what is this? This is so this is x-axis and this is y-axis. Okay, and this is z-axis. So now look at Okay. So this is a full sphere. Okay. And so what about this one? So this is a rho. This is rho axis and makes an angle phi. Okay, with respect to z axis. So it moves around z. And one more. So I want one radius axis, right? So this is r axis in the plane only, right? That's why I'm drawing from here to here, not from here to here. This is xy plane portion. This one. It should look like ellipse, but it is not ellipse. Okay. So this is r axis, therefore it is r, right? And its angle with respect to positive x axis theta. So this angle is theta. Okay, this angle is theta, right? Now let's carry out the integration over this solid. Yeah, look at now. So triple integration. Let's call this solid of integration is S. So enter sphere, right? A sphere of radius 1. If you want, you can write center it origin, right? Then this is proper one, right? Yeah. So triple integration x into dx, dy, dz, right? So since the solid of integration is a sphere, then we supposed to adopt spherical polar coordinate system. Then replace back what is x. Now x is equals to rho sin pi cos theta, r cos theta, right? So r is rho sin pi cos theta, and into Jacobian. What is Jacobian? Rho square sin pi. So this is Jacobian. Okay, rho square sin pi into d rho d theta into d pi, right? And assume this is, so this is the solid of integration r. Now this is the solid of integration s. Okay, now next one we supposed to find the limits for rho, theta and pi. Yeah, look at what I want first. First I want rho, right? So rho means it's a radius, right? So radius of the sphere. What is the radius of the sphere? A sphere of radius 1. Therefore rho varies from where to where? 0 to 1. 0 to 1. So next one, theta, right? So theta will be in the plane, so it is angle between x-axis and r-axis, positive x-axis and r-axis towards y direction, positive y direction. So therefore to generate the entire sphere, how much angle it need to be moved, this r-axis. So r-axis need to be moved in the bottom a completely it has to move. Completely means what? 360 degrees. Look at, for example, this is a hemisphere. So this below, this bottom portion I want. So right, so this is called a circle in 2D in xy plane. So to generate this entire disk in xy plane, so compulsory theta should vary 0 to 360 degrees. Therefore theta varies from 0 to 2 pi. Yeah, what is the next one? Pi. What about pi limits? So what is the pi? Actually pi is an angle between rho axis and z axis. So this rho axis moves around z, right? So it spreads like this, right? So if it spreads like this till xy plane, indirectly 90% it is spreading. Okay, 90%. So if it spreads 90 degrees, then half of the sphere will be generated. That means hemisphere. But I want full sphere, so one more 90 degrees it has to spread towards down. So overall pi need to vary from 0 to pi. Don't commit mistake here for pi limits. Don't take it as 360 degrees. So it is spreading around z axis. So this is z axis. So it is spreading like this. But up to xy plane it's spreading like this. So 90 degrees it's spreading. So towards downward again one more 90 degrees. So total pi degrees it has to spread. So therefore with the new set of limits now, so look at the limits. All these three limits are independent. So with respect to which variable doesn't matter. So order of integration is not important here. So you can do as what you want. So first with respect to rho I want to evaluate. So rho is from 0 to 1. So next with respect to pi I want to evaluate, so pi from where to where, 0 to 2 pi, and next sorry, pi from 0 to pi only, right? Next one, theta is varying from where to where, 0 to 2 pi. So you can change this order also, no problem. First with respect to pi you can do, next with respect to theta you can do, at the end you can do with respect to rho, your wish, because all these three are independent variables. All these three are independent variables. So order of integration is does not matter here. Okay. So now let us simplify the integrand. So rho and rho square. So total rho cube sine square pi, isn't it? Sine square pi into cos theta. So first with respect to rho I want to evaluate, so d rho. Okay, and after that with respect to, so let me, yeah, so first with respect to rho, so therefore, yeah, after that with respect to pi, so d pi, and after that with respect to theta, so d theta. Okay, now since first with respect to rho, therefore this will be, so integration, triple integration. Okay, so theta from 0 to 2 pi, right, and pi is from 0 to pi, 0 to 180 degrees, and rho power 3, so it will be rho power 4 by 4. Okay, and where rho is from 0 to 1. So after this, what are we having? Go back, we are having sine square pi and cos theta. So sine square pi, sine square pi, sine square pi, so d pi. After this, d theta, d theta. So theta will be, and one more term is missing here, sine square pi into cos theta, right? So sine square pi into cos theta here, like this. Okay, next one. So double integration. So when integral is evaluated, so this is 1 by 4, so 1 by 4 I'm writing completely outside, right? So what is there? So theta from 0 to 2 pi, theta varying from 0 to 2 pi, right? And pi limits, pi from 0 to 180 degrees, right? So sine square pi should be our variable, because with respect to pi we are going to evaluate sine square pi d pi. Okay, and after that with respect to theta is supposed to evaluate d theta, and sine square pi you substitute in terms of so cos 2 theta is equal to 1 minus 2 sine square theta. Sine square term in terms of cos, that means I want to substitute a linear form. So therefore what is sine square pi now? Sine square pi will be 1 minus, so let me write here, so therefore 1/4. Okay, again here cos theta is missing, you write cos theta here. Okay, so next one, so double integration, right? So pi is from where to where, 0 to 180 degrees, 0 to pi. Okay, and theta is from 0 to 2 pi, 0 to 2 pi, right? So sine square pi I'm plugging back, so what is this, 1 minus cos 2 theta 2 pi now by 2, by 2. Okay, this one I'm replacing, sine square pi I'm replacing in terms of linear function, 1 minus cos 2 pi by 2. Okay, and into a cos theta. Okay, and this one with respect to pi is supposed to evaluate, and after that with respect to theta, now in this cos theta is constant, because pi with respect to pi we are evaluating. Okay, so now this will be 1 by 4 into 1 by 2, so total 1 by 8, right? 1 by 8 integration theta from 0 to 2 pi, 0 to 2 pi. Now let us evaluate this, half is gone, so with respect to pi, so pi minus cos 2 pi integration sine 2 pi, not derivative, integration. Okay, okay, cos 2 pi pi 2, okay, and where the limits are from pi limits 0 to pi, 0 to pi. So after that, what is extra remain? Cos theta will remain t theta. Okay, so next one, so 1 by 8, okay, 1 by 8, so integration theta from 0 to 2 pi, 0 to 2 pi. Now plug in back this limits. So pi, instead of pi, substitute 180 degrees, so pi minus sine 2 pi 0, so upper limit is 0 and lower limit is 0, so pi minus 0 into cos theta into d theta. Okay, so this will be 1 by 8, 1 by 8, 0 to 2 pi, pi into cos theta, pi into cos theta into d theta. Make sure that everything is correct. So pi by 8, pi is bringing out because that is irrespective of integration because theta is a variable. Cos theta integration sin theta, and it's carried out from 0 to 2 pi. So what is this value now? So this is pi by 8, right? Pi by 8, sin 2 pi 0 and sin 0 0. So overall answer will be 0. So this is the final answer. Okay. So next problem, this one, second one. Hemisphere of radius 1 for z more than or equal to 0. Z more than or equal to 0 means what? Upper part only. So upper hemisphere. So for that, I will write the limits you carried out. Same like this only. Let me write the set of limits. Okay. So first row limits, right? For that. So row radius doesn't change, right? So 0 to 1 only for hemisphere also. Next, theta limits. So theta will be this angle, right, between r axis and x axis. Again, bottom complete circle need to be generated. So therefore again 0 to 2 pi. This doesn't change for hemisphere also. But where the modification comes for pi. Since we want hemisphere, that particularly in for z more than or equal to 0 in the upper part only. So again pi varies from 0 to pi by 2. Pi by 2 you have to write so that hemisphere will be generated. So with this set of limits, you can carry out the second integration. Same x into dx dy dz. Okay, take it exercise. Next one, problem number 2. Let S be a solid inside both the cone z is equal to square root over x square plus y square and the sphere of radius 1. Then evaluate the triple integral z into dx dy dz over the solid S. And you look at cone z is equal to square root over x square y square. If this root is not there, that is called paraboloid. Paraboloid. Since root is there, so it is a cone equation. Okay. Now this will be the region of a solid of integration. So this is a cone. So this is a cone. Okay, and this will be a cone, but the common portion we need to consider. So inside the cone, inside both the cone and sphere. So this is a sphere surface. This one, upper one is a sphere surface and this inside one is a cone. So common portion will be this one. So over this solid S, we have to carry out the integration. Okay. So look at how the integration is carried out. So triple integration, okay, over the solid S. What is that? What is given? Z into dx dy dz. Okay, and this will be triple integration over the solid S. What is Z now? Z will be rho cos pi, isn't it? Look at the transformations in the spherical polar coordinate system into Jacobian, right? Jacobian is rho square sin pi, okay, into d rho d theta and d pi. So now this will be, so our next goal is the limits, isn't it? Theta limits, pi limits and rho limits. Okay, so first I want rho limits. Rho means what? Radius, right? So radius means starting from the origin, length from the origin, right? So what is the rho axis here? So this is a rho axis. So this is the rho axis. Simply it is a radius of the sphere. Okay, it's a 3D radius. So rho varies from where to where? 0 to 1, because sphere of radius 1 is given. So rho limits are 0 to 1 over. So next one, theta limits. So theta means here the angle between our axis to x axis. So this is theta. Since this solid is around z axis, therefore this r axis should move around completely around z axis, therefore 360 degrees. So theta varies from where to where? 0 to 2 pi. 0 to 2 pi. Because this solid is around z axis completely. So this axis r axis should move completely around z axis, so that it is 0 to 2 pi. And the next one is pi. What is pi? So pi is an angle between this rho axis and let us consider, so this is z axis, right? So this is z axis, right? So this angle is pi. So this angle is pi, right? So now pi limits. So lower limit obviously 0 degrees, starting from 0 degrees to till this point, right? So till this point it is moving rho axis. From where? From z axis to this, but this angle I want, right? So this angle I want. What I point out? So look at, so this rho axis is moving from z axis to this axis, right? So therefore this angle I want, this angle. So how to get this angle here? So by using the data, so let me erase this and I will find out pi limits. So first, what is given to us? Yeah, x is equal to, since we are in spherical polar coordinate system, so x is equal to rho sin pi cos theta, rho sin pi cos theta, right? And y is equal to rho sin pi sin theta, right? Sin theta. And finally z is equal to rho cos pi. So use these three transformations perfectly and get pi value, upper bound for pi. Pi is an angle. So it is not given the problem. By using this cone equation and sphere equation, we need to get pi limits, right? Remember, I want pi. So focus on the variable pi. So now here, if I divide x and y, so sin pi get cancelled. So pi is cancelled, but I want pi should be present. So let us take y by z. Okay, if you do y by z, what will you get? So y by z, I want to do y by z. Do y by z. So equation number 2 divided by equation number 3. Okay. If you do equation number 2 divided by equation number 3, what will you get? Rho cancel out. Sin pi by cos pi. What will you get? Tan pi. Isn't it? This is tan pi and extra sin theta. Sin theta. Okay. And let us do one more. I want sin theta value. So then do 2 divided by 1. If you do 2 divided by 1, then what you will get? So you will get y by x, right? So y by x, isn't it? Y by x is equals to rho cancel out, sin pi cancel out, we'll get tan theta. So tan theta value this much, then what about sin theta value? Okay, like that I will find out. So first, what about, let's look at the graph for this. So it means what? So draw a rectangle triangle. Okay, so this is 90 degrees, right? And this angle is theta. So this is theta. Okay, now what is tan theta? Tan theta means opposite side by base. So y by x now. According to this equation, tan theta will be y by x, right? So tan theta, so theta should be like this. So theta is here and y should be here, x should be here. Therefore, what is hypotenuse value? This value. So this value should be x square plus y square by Pythagoras theorem. Okay, square root over x square plus y square, right? So from this I want what is sin theta. So therefore, what is sin theta? So therefore, sin theta will be, what is sin theta? Sin theta will be opposite side by hypotenuse. So y by square root over x square plus y square, x square plus y square. So this is sin theta value. So therefore plug in back here this sin theta value, substitute here, so that this will be how it modifies. So y by z is equals to tan pi, isn't it? tan pi into sin theta value y by square root over x square plus y square. Okay, x square plus y square, and bring this quantity to this side so that you will get tan pi value. Okay, proceed in the next bit. So y by z is equals to, so y by z is equals to tan pi into y by square root over x square plus y square. Okay, then bring this one, okay, to left hand side. So therefore first tan pi is equals to so bring this quantity to this side. So y by z into square root over x square plus y square, it will be reciprocal, right, divided by y. So now here y cancel out, so finally what will remains? So tan pi value, remember my goal is pi value, upper bound for pi, so square root over x square plus y square divided by z. But what is given to us? But z is equal to square root over x square plus y square. This is a cone equation, right? So therefore square root over x plus y square value is z. So therefore what we can write? Tan pi is equals to this value is z. So z by z, how much? 1. So tan pi is 1. That means what is pi value? So therefore pi value is pi by 4. So indirectly here pi is equal to pi by 4 means it is a cone equation in terms of spherical polar coordinate system. So this is a cone equation in spherical polar coordinate system. Spherical polar coordinate system. Okay. In Cartesian coordinate system, cone equation means z is equal to square root over x square plus y square. Okay. So that is the difference between the spherical polar coordinate system and Cartesian coordinate system. So pi is equal to pi by 4 means is a cone. So therefore directly I can write pi is equal to pi by 4 because it is a cone, but you will not understand. That's why I have given this much proof. So now the limits for pi are 0 to pi by 4. So if the cone is given, directly you can take angles are 0 to pi by 4, provided z axis will be the center axis for that cone. Okay, then only the limits are 0 to pi by 4. So since all these three are independent limits, so you can carry out the integration with respect to rho, or with rho first, or with respect to theta first, or with respect to pi first, your wish. Now let us carry out the integration over such limits. So rho cos pi, rho square sin pi. So overall, what will get? So triple integration, right? Rho cube sin pi cos pi, right? D rho d pi d theta. Okay, and since all are independent, you can, I am doing first with respect to rho is from 0 to 1. Okay, and after that let me proceed pi. So pi is from 0 to pi by 4, and after that I would proceed with respect to theta. So theta from 0 to 2 pi, so 0 to 2 pi. Okay, so now this will be, yeah, so triple integration. So theta from 0 to 2 pi, right? Next pi is from 0 to pi by 4, 45 degrees, 0 to pi by 4. First with respect to rho, so I will get rho power 4 by 4. Okay, where the limits are from 0 to 1. And I am multiplying divided with 2, so 1 by 2. So 2 into sin pi cos pi will be sin 2 pi. Okay, this is sin 2 pi. Now next with respect to pi, after that with respect to theta. Okay, so pi after theta, right? Next one, so 1 by 2, 1 by 4, total 1 by 8. So 1 by 8 will comes out, and integration theta from 0 to 360 degrees, right? and 1 by 4 already dragged out, so total 1 by 8. Now with respect to pi, sine 2 pi is minus cos 2 pi divided by 2. Okay, and where the limits are from 0 to pi limits, and after that with respect to theta, and this will be minus 1 upon 16, minus 1 upon 16. What will get? First simplify the integrand 0 to 2 pi. Theta limits are 0 to 2 pi. Already 2 is dragging out, minus 1 upon 16 cos 2 pi. So substitute the upper limit, cos 2 pi is 1 minus cos 0. Cos 0 is 1, isn't it? So it is pi by 4, right? This is pi by 4 limits. So 0 to pi by 4, right? So once we substitute pi by 4, cos pi by 2 you will get, right? And that will be 0. So this is 0, right? And lower limit cos 0 1, fine, into d theta. So finally, so plus 1 upon 16, right? And anything else? Nothing. So d theta. So d theta means it is theta. So finally d theta is left. D theta means integration d theta is theta, and theta limits are from 0 to 2 pi. 0 to 2 pi. Now finally 2 pi by 16. So pi by 8 you're supposed to get. Pi by 8. So this is the final answer. Okay. And let's take few exercise problems. Exercise problem number 10. And do solve all these problems with your own effort, and with this I will stop.